Mr. Trey Obering is a Senior Vice President for Booz Allen Hamilton, with responsibilities across the firm's entire aerospace portfolio, especially space and cyberspace. He retired from the Air Force as a Lieutenant General with over 35 years of experience in space and defense systems development operations. His final position was as the Director of the Missile Defense Agency. Ladies and gentlemen, please welcome our final speaker of Cyber 1.2, Lieutenant General Retired Trey Obering.
Good afternoon, everyone. Normally they just say that he's getting old and most of what he used to fly is in a museum somewhere, but I appreciate that. Now, some of you know me as a fighter pilot or a space and missile defense guy, so why am I discussing cyber? It is precisely because I am not a cyber warrior that I felt that it is important to give a fighter pilot space missile defense perspective and bring that to the cyber discussions. As a wrap-up to today's events and a lead into the rest of the week, I'd like to explore the challenges of cyber and space integration and how we might deal with them. This has been a major topic at the forefront of many attending this conference, and there certainly has been a lot of energy surrounding the best way to integrate cyber and space. Actually, I believe that cyber and space are already integrated, both to a degree that is advantageous to us as well as detrimental to us. In my talk this afternoon, I would like to leave you with three points. The first one is that we need to recognize cyber as a domain, the same way that we see space as a domain and air as a domain. We need networks to dynamically defend our networks of space systems in this domain. And I believe that we have a major education and training effort ahead of us. Now, a good place to start with any discussions of the challenges of the integration of cyber and space is with the threat. Overall, the cybersecurity threat is a multidimensional, multifaceted problem with capabilities ranging from individual and amateur hackers and hacktivist groups such as Anonymous, performing distributed denial of service, phishing scams, and web-based attacks, to nation-state actors executing sophisticated attacks using web-based remote access tools, custom exploits, malware injection, and many other techniques. Today, I want to concentrate on the advanced end of the cybersecurity threat spectrum, the nation-state threat. Now, just like we have to maintain space situational awareness as part of our responsibility for national security, we need to maintain cyber situational awareness as well. To gain a better understanding of factors influencing cyber power globally, The Economist Intelligence Unit has developed the Cyberpower Index. This index measures both the success of digital adoption and cybersecurity, as well as the degree to which the environment in the top 20 nations promote national cyber power. It is a dynamic, quantitative, and qualitative model constructed from 39 indicators and sub-indicators that measure specific attributes of the cyber environment across four major drivers of cyber power: the legal and regulatory framework, the economic and social context, the technology infrastructure, and the industry application, which examines digital progress across key industries. The index can be found at www.cyberhub.com. Now, going from global to local, let me relate a true story involving a major defense firm in the Washington, D.C. area. One Friday afternoon, just before Christmas in 2009, an engineer at the firm left his office to go home, having turned off and secured his computer. As he got into his car, he realized that he had left a present back in his office. When he returned, he noted that the computer that he had verified off was on. The IT team was contacted, and internal investigation ensued. It was discovered that the network had been breached, and an outside entity had been able to gain system administration privileges on the net. Further investigation from an outside specialist found that 23 terabytes of data were accessed and partitioned for transmission. No classified data was involved, but certainly proprietary data was involved. The investigation also revealed that the source of the intrusion was of Chinese origin. The FBI was contacted. They indicated it was one of many instances of that same nature. In October 2011, the U.S. released a report by the Office of National Counterintelligence Executive in which they acknowledged the role of China and Russia in international cyber espionage. As Mike McConnell, a former Director of National Intelligence and Executive VP at Booz Allen, outlined in a recent Wall Street op-ed, China has a massive, inexpensive workforce ravenous for growth. It is much more efficient for them to steal innovations and intellectual property than it is for them to incur the cost and time of creating their own. But this advanced threat is not just against industrial or governmental IT systems. In another U.S. release entitled 2011 Report to Congress of the U.S.-China Economic and Security Review Commission, several instances were documented where command and control systems for sensitive satellite systems were successfully breached. The report goes on to suggest that such events are in line with Chinese military doctrine. These events are described here, and I quote from the report, not on the basis of specific attribution information, but rather because the techniques appear consistent with authoritative Chinese military writings. For example, according to military astronautics, attacks on space systems, quote, generate tremors in the structure of space power of the enemy, cause it to suffer from chain effects, and finally lose or partly lose its combat effectiveness, unquote. One tactic is, quote, implanting computer virus and logic bombs into the enemy space information network so as to paralyze the enemy space information systems, unquote. As Kevin Coleman, a senior fellow with the Technolytics Institute, former chief strategist for Netscape and author of the book, The Cyber Commander's Handbook, pointed out, quote, most of the satellites in orbit were designed and built before the realization that cyber attacks would become so prevalent across all communications platforms. In 2006, the Bush administration warned of threats by terrorist groups and other nations against U.S. commercial and military satellites. Lately, reports of sophisticated cyber attacks on satellites have surfaced. It is commonly believed that Chinese military planners have determined that the greatest weakness in the U.S. military is its reliance on computer and satellite systems. The threat is not in the future. The threat is today. Cyber attacks against satellites are already here. Cyber attackers prey on those who don't protect themselves, and our fleet of satellites is now a prime target. This requires immediate action, unquote. Cyber attacks against our space systems could result in critical dropouts or interference in the data downlinks of the systems, loss of situation awareness of a single satellite or constellation, loss of command and control of a single satellite or constellation, intentional manipulation of onboard sensors that provide imagery, intelligence, missile launch detection, and many other functions from space, and then physical loss or damage to the satellite or constellation. Now, this brings us to a key point in my mind regarding the integration of cyber and space. We can't just think of defending our space systems against cyber attacks the way we think of defending business, social, or infrastructure IT systems. We must recognize that the cyber domain is in fact a true domain in and of itself. We have to better understand this domain and learn how to operate in it. For example, we did countless studies and spent significant resources as a nation to characterize the air domain in the 50s and the 60s. We then used that information to develop the technologies for the modern fighter and transport aircraft in operation today. Likewise, we spent incredible resources to characterize the space domain in the 60s and 70s so that we could develop the technologies in use today for our space systems to operate. But in spite of the explosion of cyber as a domain really beginning in the 1990s, we have yet to characterize it using the same robust approach. We have to understand that we operate space systems in the cyber domain in the same manner that we operate our space systems in the space domain or our aircraft in the air domain. In other words, just as the attributes of the space environment, the vacuum, the radiation, the extreme temperatures, the orbital mechanics, have to be factored into the design and operation of our space systems, so do the attributes and vulnerabilities of the cyber domain, the communication links, the data storage and accession and handling, command and control protection, the networking, the architecture and the management of the network, all have to be taken into account and engineered into defending our space systems. cybersecurity has to become part of the overall systems engineering process from the very beginning. We have to address cyber capabilities and vulnerabilities, starting with the requirements definition, the architecture, design, development, production, and supply chain management of our ground infrastructure, the user equipment, and the space platforms. One example of help available to the system engineers and designers is the Cyber Solutions Network that was created by my firm. This tool virtually connects clients more effectively with thousands of cyber experts, technologies, and solutions through one unique network. This network of centers enables innovation and provides advanced cyber analytics, computer network defense, cyber product testing and evaluation, and advanced cyber training delivered through virtually linked constellation of centers, labs, and stations. The initial network includes 9 centers. Now, in today's modern warfighting environment, integrated distributed operations are more and more critical to success. In my previous life as director of the Missile Defense Agency, we developed the ballistic missile defense system that protects our country and our forces, our allies, based on such a construct. The BMDS is a very complex network of satellites, land and sea-based sensors integrated with sea-based and land mobile and silo-based interceptors. A testament to the success of the integrated capability was Operation Burnt Frost in February of 2008, when we tied together the land and sea-based sensors with sea-based interceptors to shoot down the out-of-control satellite with the toxic fuel tank on board. But these integrated network elements also introduce new vulnerabilities from a cyber domain perspective, and it presents another challenge to address in the integration of cyber and space. The disaggregation and networking of space systems is being brought about in part by the increasing ASAT threat. In a superb article published this spring in Strategic Studies Quarterly by Lieutenant General Palakowski, Mr. Livero, and Colonel Chrysler, entitled Space, Disruptive Challenges, New Opportunities, and New Strategies, the conclusion is made that in order to address poor space capability resilience, fragile constellations, declining budgets, and a fragile industrial base, the U.S. needs to use more distributed architectures and payload-focused acquisition strategies which leverage the highly competitive commercial satellite bus market and hosted payloads on commercial, international, and allied platforms. This conclusion is the right one to meet those challenges. But what are the implications for the challenges of cyber and space integration? If we use the system engineering process as a guide, we would begin with ensuring that the requirements for the operation of the commercial satellites and buses in the cyber domain were adequately addressed, as well as ensuring that any vulnerabilities operating the network of disaggregated payloads in the cyber domain are defined early and mitigated in the architecture. In addition, there would have to be some degree of assurance with the pedigree of the supply chain and the vendors for the payloads, the commercial buses and satellites, for the possibility of malware and logic bomb injections, along with backdoor access insertions. These capabilities to operate in the cyber domain and protections would have to be adequately tested as well. Now, designing our space systems to operate in the cyber domain also requires the ability to deal with a very dynamic and sophisticated threat. Many believe that adversaries have penetrated even our classified networks today. So no matter how carefully we may design our systems, no system or network may be 100% secure in today's environment. We must proceed on the assumption that the enemy exists today throughout the cyber domain. In order to deal with this challenge, we need to develop the ability for dynamic defense. A dynamic defense would combine the best elements of a traditional defense and the strategic targeting of the most lethal threats. A dynamic defense anticipates and identifies growing threats before they hit, and identifies who is about to move and what attack is most likely to occur, proactively prepares the system to defend itself against a threat, and monitors for the anticipated attack and fends it off. A dynamic defense would result in a resilient enterprise capable of using a network of systems to defend the network of systems. It is an enterprise that is capable of constantly changing configurations, data access and routing, command and control paths. It prevents an enemy from taking advantage of static vulnerability windows and security flaws. To achieve a dynamic defense, we need to focus on things like data correlation. Organizations should correlate data across existing devices first. Each device and server has a piece of the puzzle. Only by putting all the pieces together can organizations get a clear picture of the whole. threat intelligence analysis. Many of the products in the security industry are very similar in how they work and operate. The key then to effective security is having accurate and up-to-date threat data. Since organizations cannot fix every risk, they need to focus on the most likely attack vectors so that the proper vulnerabilities can be addressed. Endpoint security. In terms of the data they contain, there's little difference between a server and a laptop or other mobile device. However, the server is on a well-protected network usually, and mobile devices are usually directly connected to untrusted networks, including the wireless. As more and more devices become portable, the processes for controlling, monitoring, and protecting data at the endpoints become critical. Proactive instead of reactive forensics. The problem is that technologies are often built for functionality with minimal security embedded into the hardware and software. To avoid damage, organizations must put more energy and effort into proactively identifying problems and avenues of compromise. Shifting focus from data encryption to key management. Encryption is the solution of choice for many organizations. However, encryption is ineffective if the keys are not properly managed and protected. Keys obviously should not be stored with the encrypted data. Finally, in the challenges of integration of cyber and space include a major effort in the area of education and training. From understanding the cyber threat to our space systems, to the realization and incorporation of cyber as a domain in the design and operation of our space systems, to the creation and implementation of capabilities such as dynamic defense, we need to assess our current education and training requirements, processes, and approaches. In the past, we've expended considerable resources to educate our officers, airmen, and civilians to prepare them for their jobs in the air and space domain. We have to make sure we do the same very robustly for the cyber domain. One tool available is the Cyber Solutions Network that I mentioned before that hosts 3 major centers to provide intensive technology-based cyber training, which is an essential component to build capabilities from basic familiarity to advanced cyber skill. But more strategically speaking, we need to support initiatives to create cyber engineering degrees, consisting of a combination of electrical engineering, computer science, software engineering, and communications engineering elements. So as you approach the next several days, it's important to understand the interdependencies of cyber and the space domain and the synergies essential for mission assurance. I hope that you've enjoyed your day today, and I look forward to seeing you the rest of the week. I look forward to any questions you may have.
Thank you, General. First question. Is the U.S. doing enough to protect future space systems from cyber attacks?
I think, and I'm not have inside information in that regard, but I will say this. I think that the recognition of having to operate in a very contested cyber domain, when that realization is translated into requirements, and those requirements are adequately put through the system engineering process for space systems, I believe that that's the way that we have to get to that, as opposed to thinking about it as an add-on or bolt-on after the fact in terms of that protection. So it has to become a requirement, as any of the other requirements for operating in the space domain, that we understand it's going to be in a contested cyber environment.
Sir, next question. Might a more distributed space architecture introduce more cyber vulnerabilities while reducing physical vulnerabilities?
And that was the point I was making, is that while we're just going to disaggregation and to distribution, it does open up and could open up vulnerabilities from the network perspective. That's why you need a network to defend the network, and especially one that can be dynamically reconfigured to be able to anticipate and to provide that defense.
Sir, that's all we have for you today, unless anyone else has any other questions.
Scott?
Yeah, in the past, military sometimes separates defense and offense for the way that they look at the doctrine. That's, I think, because the timelines were such that that allowed that kind of capability. Now with timelines in nanoseconds, do you see it might be different to have defense and offense almost in the same person, in the same place when you talk about dynamic?
Absolutely. I think that is, in fact, it's almost it will be a necessity in terms of how we operate. It's often thought of as not a football game; it's a soccer game, and you have to be able to go back and forth to be able to successfully operate in that domain. Again, those are some of the requirements, and that's the type of thinking that we have to make sure that we get incorporated into our systems design and operations.
Are there any other questions?
Okay, thank you very much. Have a good week.
Thank you, General, for sharing your insights and experiences. Ladies and gentlemen, if you have any further questions for the panel members or any of our other speakers that were here today, please join us at the Cyber 1.2 networking reception, which will take place in the rear of this room starting at 4:30. We hope to see you all there and at this evening's opening ceremonies of the 28th National Space Symposium. This concludes Cyber 1.2. Thank you all for your participation.